All right. So we've seen that the brute force way of doing things, where we look at every possible permutation of our list, probably not the way to go. Let me talk about something that is substantially better, but still considered to be bad, to the point where even Obama knew that it was bad in the 2008 presidential election, as I show in the clip below. But, so he had good handlers. But anyway, so let me just, it's probably easier to show in code, and then I'll link a few animations below. I'm not even going to bother making you code this one, but I do want you to pay attention and see how it's done. Okay, so here's how it works. So what I want to do is, so for some number of iterations, I want to do the following step over and over again. I'm going to say for I in range n. And if I find that two elements, actually let me say for I in range n minus 1. If I find that two elements are out of order, I swap them. So this is what a lot of people were starting to do in class. So if I find that, you know, the array at index I is greater than the very next element, then I'm going to swap them. Okay. So, all right. But that's not enough. That I actually have to do over and over again. So let me show you what I mean. So I'll define a variable called swapped. I'll say that's true, or let me call it did swap. So I'll say while did swap, I'm going to do this thing. So I'll start off by assuming I didn't have to do a swap in this whole loop through. So if I get an array that's already in sorted order, this thing's never going to happen. So let me start off by assuming I never did that, but as soon as I have to swap, then I remember that. Okay. And that's it. All right. So what I'm going to do is every time I do a swap, I'm going to print the result. I'm going to print the index just to show you how this is working. Okay, let me run it. So let's say I have the array, you know, maybe 5, 4, 3, 2, 1. So I put an array that's completely in reverse. Let's see what this does. Okay, so the first thing it goes through, it says, it goes through this inner loop. I is 0. I find that 5 is greater than 4, so I swap them. Okay, next, at index 1, I find that, okay, 5 was at index 1. I find that 5 is greater than 3, so I swap them. Now I'm in index 2. I find that 5 is greater than 2, so I swap them. Finally, I'm in index 2. I find that 5 is greater than 1, so I swap them, and I'm done. Okay, now I go back to the beginning. I find that 4... So I did a swap, so I've got to repeat this whole process again, starting at the beginning. I find that 4 is greater than 3, so I swap them. Then I find that 4 is greater than 2, swap them. So the reason this is called bubble sort is because the big elements bubble to the top. That's the idea. They keep swapping with things next to them until they get to the top. So first the 5 makes its way to the top. And then eventually the 4 makes its way to the top. Then the 3 makes its way. And then the 2, and then the 1. And this actually is an algorithm which is big O of n squared. And the reason is because this inner loop takes n steps. Even if I don't do a swap, I still have to check to see if I need to do a swap. So there are, you know, some constant times n operations in this inner loop. And it's possible that, you know, we're going to have to bubble every single element to the top, and there are n elements, so it's actually n times n. So this is an n squared algorithm in the worst case. Best case, I happen to give you an array that's already sorted, and it breaks out of the loop after the first one of these inner ones. So actually the best case in this implementation, so it's worst case of n, but actually it turns out to be best case omega of n. Because if I give, you know, so we can see this is worst case of n squared for an array that's completely reversed. Best case omega of n for an array that's already in order. Because if an array is already in order, then we just break out after the first loop. We didn't have to swap anything, so we're like, okay, we're done. All right. Now let's go to our complexity cheat sheet, and let's see what they say about this algorithm. So, okay, just like I told you, n factorial is worse than 2 to the n. They're all considered horrible. N squared is also considered horrible, so that's not good worst case performance. What about average case? Well, if we look at bubble sort, it turns out the average case is also n squared. I'm not going to prove that right now, but that's not great. Okay. But even just in implementation, this is worse than some other options that we have. So I want to move on and talk about some other options that are still O of n squared, but considered better in practice. Okay. For a variety of reasons.